This video lecture supplements a workbook for Beck's Introduction to SQL Programming, the Pelican Companion. The corresponding textbook is Beck's Introduction to SQL Programming, that Pelican database book. The workbook and printed copy of the companion textbook may be purchased from lulu.com. You may download the textbook for free in ebook format from beckplanet.com/books. Important note on SQL Server and MySQL. The material presented supports both the SQL Server and MySQL environments. Where differences in SQL dialect and environment arise, solutions for both environments will be demonstrated. Where the SQL code is common across environments, only one environment is used for demonstration, as the code runs identically in the other environment. Chapter 2, Parallel Exercises. Solution Walkthrough with Commentary. Preparation. Make certain you have connected to your DBMS, SQL Server or MySQL, using your query client, e.g. SSMS or MySQL Workbench. If the Candy database already exists, it's a good idea to start by dropping and recreating it so that everything is in the expected startup state. Run the Candy database creation script appropriate to your DBMS, SQL Server or MySQL. Review the script execution results to ensure that the database and its data were successfully created. Parallel Exercise 1. Using the Candy database, list all rows and columns for the complete Customers table. As we begin our parallel problem exercise set, let's use a template to help us learn to structure our SQL code. We'll start with a simple template that includes a select, a from, a where, and an order by clause. We will preface each clause by a double dash and a space, which denotes a comment in SQL code. Then, we will uncomment the clauses we need as we compose our code. Our first problem asks us to return all fields of a table, so we can use the asterisk or wildcard operator to select all available fields. The problem also states that we are to use the client table, so we will add that to the from clause. Finally, we can uncomment the clauses we've used and delete the clauses we don't need from the template and test our code. Parallel Exercise 2. Using the Candy database, list only the description and price of products whose price is 43 cents or more. Using our template, we can chip away at the requirements for this problem. We will start by selecting all fields from the product table. We can run the query we are developing at different points in the development to check our progress. This is an excellent learning strategy and a good development practice. Next, we can add the appropriate where clause to filter for only those records where the price is 43 cents or more. Finally, we will reduce the selected fields so that only those required by the specifications are displayed. Parallel Exercise 3. Using the Candy database, list only the order num for each order for client num 586, dated after August 22, 2021. The problem statement for this exercise did not explicitly list the table we need to use. However, by examining the fields we are to use in our logic, we can deduce the necessary table. This is where an entity relationship diagram for the schema is very helpful. Looking at the Candy ERD, we quickly see that the order num and client num fields are both present in the orders table. An interesting aspect of this problem is that we are to display only the order num field, but we are constructing logic involving the client num. Beginning DBAs often find it strange that we can build logic on fields that are not displayed, that is, not part of the select clause. This is important to understand. As in previous examples, we can start with our template and select everything. Then, we can add filtering with the where clause, checking our progress by running the code as we develop it. Another thing that can be a bit tricky is making sure that we encode our date using either a proper date format for our DBMS or a format that our DBMS can implicitly interpret as a date type. Once we are happy that the where filter meets requirements, we can alter the select clause to display only the required field. Parallel exercise 4. Using the Candy database, list only the client name and credit limit for each client residing in postal code 91356 or 93001. Once again, we can arrive at our solution incrementally, starting with our template and selecting everything from the client table. Our filter requires us to limit results to records with postal code value of 91356 or 93001. Beginning DBAs sometimes confuse the OR operator and AND operator. Taking a moment to think and talk this through, it quickly becomes clear that an address can only be in one postal code, so the OR operator is required here. After all, an address cannot be in both 91356 and 93001 postal zones simultaneously. Clearly, we want all records that are in postal code 91356 or in postal code 93001. If this seems confusing to you, try experimenting by replacing the OR operator with the AND operator and observe the results. You will soon get a feel for using the Boolean and OR operators. Parallel exercise 5. Using the Candy database, list only the sales agent num, last name, and first name of each sales agent that is not sales agent number 2. Exercise 5 is an excellent example that it is sometimes simpler and clearer to define a solution by exclusion instead of inclusion. Our solution for this problem is best expressed in terms of a filter of records where the sales agent num is not equal to 2. Parallel exercise 6. Using the Candy database, list only the product number, description, and price for each product that has a price between 37 cents and 41 cents inclusive. Do this two ways, one using the between keyword and one using the and keyword with comparison operators. The key part of the analysis for this problem is to understand that the range here is inclusive. The between operator is inherently inclusive. In other words, the beginning and ending values in the range are included in the results. When implementing this with comparison operators, we will need to use greater than or equal to and less than or equal to comparisons. In any event, the results of both correct solutions will be identical. Parallel exercise 7. Using the Candy database, list only the product number, description, and computed column Ferrara candy sale price for each product of manufacturer number 5. For this manufacturer, the business is offering a sale price discount of 15% off of the regular price. Assign the name Ferrara candy sale price to the computed column. A cursory analysis of this exercise shows us that the primary challenge here will be composing a calculated field and remembering to alias it to the specified column name. Parallel exercise 8. The formula to calculate a suggested retail price, SRP, based on a percentage markup is SRP equals wholesale price times percentage markup. Note that the price stored in the product table is the wholesale price. Using the Candy database, list only the product num, description, manufacturer number, and the computed column, suggested retail, for each item whose SRP is under 17 cents. Assign the name suggested retail price to the computed column. The solution to this exercise will once again require composing a computed field and aliasing the column name, but we will also be filtering on a comparison involving a computation. We will also need to use the order by clause to achieve the required ordering of the results. Parallel exercise 9. Using the Candy database, use the IN operator to list only the client's name and balance of each client in the postal codes of 93001, 93030, or 93101. To solve this exercise, we will need to use the IN operator. You will recall that the IN operator works with a comma-separated list of values. Anytime you would otherwise need to use a compound OR clause involving more than two choices, it is wise to consider coding with the IN operator instead. For lists of more than two choices, code that uses the IN clause is more compact, more readable, and easier to maintain. Parallel exercise 10. Using the Candy database, list only the client number and postal code of each client whose first name has E as its third letter. Our solution for exercise 10 requires application of advanced wildcard operators. Here we will use the familiar percent symbol denoting any number and type of characters, but it will also require the underscore wildcard operator. The underscore denotes a wildcard match of any single character. To ensure that the third character of the field we are matching contains the letter E, we will preface the search string with two underscore characters. Parallel exercise 11. Using the Candy database, list all details about all clients by using the wildcard operator asterisk. Order the output by zip code in descending order. In exercise 11, we are required to sort the results in descending order. This will require the addition of the DESC keyword to the order by clause. We may add the ASC keyword to explicitly order results in ascending sequence, but ASC may also be omitted since it is the default. To order in descending sequence, we must add the DESC keyword. Parallel exercise 12. Using the Candy database, list all details about all clients. Order the output by postal code descending, and within postal code by client name ascending. Exercise 12 involves sorting on multiple keys. This is like sorting within groups. The first sort criteria is the major sort key, and additional criteria are called minor sort keys. Each key can be sorted ascending or descending independent of the other keys. I recommend experimenting with multiple sort keys to get a clear understanding and a feel for how major minor sort keys work. Parallel exercise 13. Using the Candy database, determine the price a client would pay to buy a sampler of one piece of each candy by manufacturer number 7. To do this, use the sum function. Alias the summed field as Hershey sampler price and display only this field. In exercise 13, we will use an aggregate function. In this case, it will be the sum function. This exercise example is one of the simplest applications of using aggregate functions as it returns one aggregate result for all the records in the result set. We will revisit more sophisticated use of aggregate functions when we explore groupings using the group by clause in future lessons. The group by clause will allow us to generate aggregate calculations for each group in the result set. Parallel exercise 14. Using the candy database, display only the average price of all candies. Label the column Average Candy Price. Here is another example of a simple application of an aggregate function. In this case, we are calculating the average for a field in the result set. Parallel exercise 15. Using the candy database, list only the product number and price of all products whose description contains the text string LK and whose price is more than 40 cents. In exercise 15, we will construct a wildcard search string to find all occurrences of a field containing LK anywhere within the string. The filter will also restrict results to matched records for which the price is greater than 40 cents. Thank you for watching. Please visit beckplanet.com/books for additional free student and instructor learning resources, a free ebook copy of Beck's Introduction to SQL Programming, that Pelican database book, and to learn more about print editions of the textbook and workbook.